Welcome to lesson 6, the cosine law. Sorry about the length of the last lesson. I know it was really long. It's really long and for such a small detail, but it's an important one in grade 11 to show that you can figure out where there's more than one triangle. All right, so now we're on to the final trig law that we need to know, and that's the cosine law. And this is basically every time you're solving a trig problem, because people always ask, well, how do I know when to use cosine law and how do I know when to use sine law? Just always start by using sine law. That's the thing. Start with sine law, and then if it doesn't work because you realize you don't have enough information, that's when you go use cosine law. So to use sine law, I'm just going to kind of write a little detail up here. To use sine law, you have to have, let me make it a little bigger, sorry. To use sine law, you have to, I'm just going to draw it right in here. To use sine law, you have to have an angle and the side across from it. You have to have one angle and one side across from it. Any triangles that you have one angle and one side across from it, you can use sine law, definitely, and you're good to go. All right, so when you don't have that situation, you might not even notice till you start setting it up, and you're like, wait a minute, it doesn't work. That's when you have to use cosine law. So look here, in both these scenarios, in the side angle side or three sides, so side angle side or just all three sides, in both those scenarios I don't have an angle and a side across from each other. Now in this case I have this angle but I don't have the side across from it, so that's not going to work. And in this, none of these know the angles, right? So none of them have the angle across from it, so none of them are going to work. So those are the scenarios where we have no choice and we have to use cosine law. Now the sine law and cosine law, I'm not going to spend time developing them, the formulas where they come from, just because of time constraints and trying to keep it to the most important information. But you can look up on YouTube. There's lots of videos. I can even make a separate video, or it's probably easy if I just share a video of someone else doing it because there's so many of them out there. But if you're really interested, do a YouTube search on the development of the cosine law or the development of the sine law. Or if you want me to make a video later, I can do that also. Just let me know. All right, so for now, we learned them in grade 10. Here it is. The cosine law states this. Here's the three versions of the law. It's the same thing. It just depends on whether you're solving for A or B or C or angle A or angle B or angle C. It really doesn't matter. You don't have to memorize all three. It's just a good idea to know one. And the one that most people know the best is this one, the third one. Why? Because look at the first part of it. It's just basically Pythagorean theorem, right? C squared equals A squared plus B squared. And then you minus 2AB cos C. So this is the one I usually just start with. I start with this. So how do I keep it straight? How do I remember all the details of it? Whatever's at the front, the side, so this would be side C. At the back, you're doing cos of the angle across from it. So that would be the angle. So notice in all three versions, A at the front, A at the back, B at the front, B at the back. Okay, so you basically start with that. And then in the middle, you have the A squared plus B minus 2AB, or look at the other versions of it, right? The other two letters are in the middle. So the one I like to use the most is I just usually start with this one here, and then I just kind of fill in whatever letters they give me in the question. All right, so for the most part, I'll use this version of it, but you can use whatever version you want. It's the same formula. It's just different letters replaced, right? They're all the same. If they're not different. There's nothing else to say about it. Okay, so the big tip, though, is at the bottom here. After you have used cosine law once to determine the first piece of information, you only need to use cosine law once. Okay, cosine law is a little more involved, a little busier, a little more work. Do not keep using cosine law, okay? Just use it to find one piece of information. Once you have that one piece of missing information that you need, you can use the sine law to solve for the rest of the information, which is way easier to use, okay? So any question using cosine law, only use it once. After that, use sine law to solve for the rest of it. So what am I solving for? Well, in this first scenario, let's look at the side angle side triangle, okay? I have no choice. I would have to solve for this side first that's across from the angle. So I would have to solve for that. Now, with the side one, it's up to me. I have to solve for one of the angles, but here's the secret. There is one little trick, okay? You can run into a problem if you solve for the wrong side first. So which side or which angle? We have to solve for an angle first, right? So which angle do you solve for first? Solve for the angle, and make note of this, okay? Solve for the angle across from the longest side, okay? And we'll talk about more why later. The longest side. There's just so much data to talk about in such a short amount of time, and I'm already boring you with super long videos covering just the basics, okay? But for now, solve for the angle across from longest side. So let's say this was 5, this is 6, and this is 7. I am going to solve for this angle here first, okay? So I'm going to walk you through one of each. One where we're solving for a side, one where we're solving for the angle, and there isn't much to it. So this should be a much shorter video than the previous ones. Okay, so here's our first example on our handout. We have no choice. We have to use the cosine law. Why? Well, if I want to use the sine law, like we said at the start, or I said at the start, we have an angle here, but to use sine law, you also have to have the side across from it. We don't. So you have to have one angle and one side across from each other for sine law to work. So let's say you don't even notice it. You just start solving like normal, and then you realize it's not going to work. That's when you go to cosine law. Okay, so step 1. We have no choice here. Let me just write this down. Step 1, we are going to solve for the side across from the given angle. So let me just write this all down so I have a nice complete note. Solve for the side across from the given angle. All right, which would be side B. We have no choice. You have to start there. You can try, but you're not going to get to work any other way. Now, when writing down the cosine law, you can use any variation of it, but since we're solving for side B here, I guess I'll use it where B is isolated. So here's how I remember it. I just start with whatever letter I'm looking for. I write B squared on the one end, and I go all the way to my other end, and I write cos of B. Basically, whatever letter you're solving for or working with, the angle and the side, B and B, they have to bookend. They have to go to the two ends of the formula. Now, the rest of it, there isn't much to it. Yeah, it's a little bit of memorization, right? It's the other two sides squared, a squared plus c squared. So it's basically Pythagorean theorem, so we got the letters mixed up now, minus 2ac, those same two letters. Oops, I accidentally deleted the big B from the end. Okay, so let's just substitute everything we know in it. And this would be little side c, this would be little side a. All right, so here we go. B squared equals a squared, which is 12 squared, plus 10 squared, minus 2 times 12 times 10 times cos of 70 degrees. Now, here's where you might want to store numbers in your calculator or do, store, just be really careful. So let me talk about what I would do here. First thing I'd like to do is I'm just going to square root this whole thing to get rid of this square here, right? So to get rid of that, we're going to square root both sides. So we square root this side, it gets rid of the square, and let's square root the other side. All right, so let's do that. So I'm going to square root the other side. I'm not going to actually calculate it yet. I'm just going to write it out. Now, what I do is I'm going to square 12, square 10, right? 12 squared is 144, 10 squared is 100. Add them together, and we're going to get 244. All right, now this whole mess here, I'm going to do all this on my calculator also. So what I would start with is the cos 70 here at the end. So I type in cos 70, I times it by 10, I times it by 12, I times it by 2, and that's what I'm going to subtract from 244. So I get about 82.008. Now again, when I'm doing this on my calculator, what I do is I just store that number and then I subtract it from 244, and then I take the square root of it. And just to save time here, we get B is approximately 12.72. And I'm going to write ... because to get the rest of the answers, if you want to be really accurate, and again, this is for those of you that are going to continue into fields in university that require mathematics. If you don't care, fine. But for those of you that are continuing, we need accuracy. So this number right here that I just got, store it in your calculator. This would be a good time to learn how to store numbers in your calculator. Look up a video on YouTube about how your calculator works. Just look up how to store numbers on, and then type in the numbers, the numbers on the front of your calculator. Maybe it's a TI 30X or something like that, or a Casio, whatever. Where do you store it? So that way you have that full number stored in your calculator. All right. So we just got B, because you don't want to round it off here or you're going to get an inaccurate number, okay? So side B here is 12.72 approximately, but I'm going to write ... meters, right? Because there's more decimals to it. Okay, now we've got that. Our next step is you don't need to use cosine law anymore. This is where people kill themselves. They keep using cosine law. It's way too much work. So I'm going to go up here and do step 2 up here. All right, step 2, use the sine law to solve for one of the other angles. So use sine law to solve for another angle. And it's up to you which one you go for here, okay? Another angle. So pick one. So I'm going to solve for, I guess, angle C. Doesn't really matter. Okay, so I'm going to solve for C here. So I'm going to start, again, use the sine law. It's way easier. Don't keep using the cosine law. You don't get bonus points for making it harder on yourself. Just use the sine law after this. You should only ever need to use the cosine law once on any triangle, okay, at most. So sine C over the side across from it is 10. Sine A, B, because we don't know A. Now that's 70 degrees, and now this is where I want to use that button on my calculator where I saved it, right? So I'm just going to write 12.72. I'm just going to write dot, 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 because there's more decimals. So what are we going to do? We're going to multiply by 10, and then take the sine inverse to get rid of sine. So when I write it out, we're going to go C equals the sine inverse of 10 times sine of 70. So type in your calculator. Sine of 70 times it by 10, then hit divide, and then hit the recall button or your memory recall button divided by 12.72, because this really does have a big effect on the accuracy in these questions, okay? All right, so you bring that back, and then you do the sine inverse of that. And again, this would be a good thing when you're following along. Try it in your calculator and see if you can get the same numbers I got. And I get 47.6 degrees approximately. So I'm just going to write that on my diagram, 47.6 degrees. Okay, so we've got almost everything here. The final thing to solve for is angle A. So we already have, right, two of the angles, so find the third angle just by subtracting from 180. So find third angle. And that is the first example for cosine law. So we're going to find angle A. You got 180 degrees in any triangle minus the other two angles, 70 minus 47.6 degrees, and we're going to get approximately 62.4 degrees. There you go. So let me just write all my missing information in over here on my chart. All right, so B is, now here I'm going to round to one decimal place because my final answer, but you don't want to round when you're actually doing the calculations, right? And C, we got about 62 point, oh, that was A, sorry. A is 62.4 approximately. 0.4 degrees. Oh, those fours keep getting written like nines. And C is 47.6. That's driving me nuts, those fours getting connected. All right. So there we go. We solved the first one. So that's a side angle side. The nice thing with side angle side, you have no choice. You have to solve for the side across from the angle you're given. And you can't use sine law, so you're stuck. There's no choice. All right, so let's look at the next scenario here. Okay, so the next scenario is we have a side triangle, and we have to solve for the angle. So let me just write out one of our versions of our formula here. It really doesn't matter which one. I'll just go with the first one. A squared equals B squared plus C squared, right? Minus 2BC, and then cos of whatever you started with, right? Cos of the angle. It's A at the start, A at the end. Okay, so now to solve this, you can start by substituting all the numbers into it, or you could just rearrange the formula to start and use the rearranged formula. It's really up to you. I usually just substitute the numbers in and then just deal with it as I go. But I'm going to rearrange the formula here just to show you how you could use that instead. So let's isolate angle A, okay? Let's isolate the capital A. So how would I do that? Well, first thing I do is I would subtract B squared and subtract C squared, negative 2BC cos of A, right? What's the next thing I do, right? Well, I divide everything by negative 2BC. So I divide this side by negative 2BC, divide this side by negative 2BC. Now, if you want, it'd be a little neater because we have a negative on the bottom. I'm just going to divide everything here by a negative, and all that's going to do is switch the signs. That's going to be a negative, that's going to be a positive, and that's going to be a positive. So, and I'm going to switch the order around. So I'm going to put the B squared plus C squared on top, and I'm going to write it minus A squared divided by 2BC, and that equals cos of A. And then all we have to do is do the cos inverse of whatever that big mess on the other side, and that's what A is. So I'm just going to flip it around here, put the cos inverse over here. So here's, if you're someone who just wants to start right with the final formula, here you go. Now I don't memorize this. I never even do it this way, but there you go. If you wanted to see it, some people like it this way, okay? So this would allow me to solve for the angle, right? Any angle, whatever, I'm A in this case, right? using all the sides, okay? Now, I'm not going to use that in my next example, but if you'd prefer to use it in your homework, go for it. So I'm going to move down and check out the example on the page. Okay, so here we go. Just to save time, I have the triangle drawn ahead this time. And so you just start drawing it like normal. You draw a triangle and then you realize, oh, I have no angles, right? Well, it's impossible to use the sine law because you have to have one angle and the side across from it. So it must be cosine law. So now let's pick which side to do first. Now this is the thing I said earlier on. This is where we have to be careful. When you have a side triangle, you have no angles, okay? If you don't want to have any problems, run into any issues, okay, find the angle across from, okay, the longest side first. All right, because basically this boils down to whether we have an obtuse triangle or do we have an acute angle triangle. And if we have an obtuse triangle, an acute angle, we're using cos. If you remember back to what we were learning about how the angles of cos and what it gives us, it might not give us that obtuse angle. So we can talk more about that later. Let's just solve this one for now. So all you need to know to start is find the angle across from the longest side first, okay? All right, so let's do that. Longest side first. All right, so that shortens our window. We're going to have to solve for angle A because 9 is the longest side. All right, so let's do that. So here we go. Step 1. Let's solve for A, okay? Solve for angle A. All right, so since I'm solving for angle A, I'm just going to set my formula up with A's on the end, okay? So A squared on this end, and then I always go to the other end and I write cos of A. And A squared, oops, that doesn't make sense. We can't have an A there, sorry. I'm thinking of Pythagorean theorem. B squared and C squared. We put the other two sides, minus 2BC. They go in the middle. All right, so let's just sub in everything we know and away we go. We know side A is 9. There's A. Let me label these. There's B. There's C. We know B is 5. We know C is 7. 2 times 5 times 7. Cos of A. What the heck is A? We don't know. That's what we're solving for. Okay, so let's just start solving, right? I'm just going to go, okay, well, let's square each of these. I'm going to square the 9, square the 5, square the 7, and then move them to the other side. I'm just going to write it like this. 9 squared minus 5 squared minus 7 squared. That's what I do. And then the next thing I do is I'm just going to divide by the negative 2 times 5 times 7. Now, you can calculate it all if you want, or you can just write it down, right? So I'm just going to write it down like this, right? I'm not even going to calculate anything yet. Divided by negative 2 times 5 times 7. Now, watch out for that negative. That's the one thing I got to warn you about. People always mess up the signs here. So let's be careful and let's actually calculate this, okay? So 9 squared is 81 minus 25 minus 7. What do we get? 7 is what we get here. Now, sometimes you'll get a negative, sometimes you'll get a positive, right? Now on the bottom, negative 2 times 5, we got negative 10 times 7 is negative 70, right? Now you could reduce this, but we got to be careful. If you don't have the negative in your answer there and you start doing the cos inverse, things can go wrong. You can get the wrong answer, okay? So we're going to take the cos inverse of that. You can reduce it or not even bother. So I'm just going to flip it around here and go A equals the cos inverse of, and just punch that all in your calculator, okay? Just be really careful. Is it negative or not? Because sometimes that top number there would be a negative and the two negatives would cancel out. That is the number one error that gets made here. All right, so you punch that on your calculator and we get angle A is approximately 95.7 is what I got. Now again, I'm storing this number in my calculator, so I'm going to go like ... I store that in my calculator to use later. Okay, so I'm just going to go draw that on my diagram there. 95.7 degrees approximately. I'm going to write it up here in my answer box. 5.7. 95.7 degrees approximately. Now again, if you round it off and use the round it off answer in the next step, you're going to get less and less correct answers as you proceed through the rest of the question. So it's the best, and again, those of you that are continuing are going to have to learn how to use that storage button. It's just generally you hit store and then you pick which slot you want to store it in, and then when you want to recall it, bring it up, you generally hit recall or memory recall, and then you'd usually pick which slot it's stored in. Every calculator is a little different, so you'll have to do a little research and practice to see if you can get it to work, okay? All right, now, like I said in the previous question, once you've done cosine law once, you do not need to use it again. So step 2, I'll squeeze this guy down here. All right, step 2, use sine law to find another unknown angle. So use sine law and find another angle. Find another angle. All right, so it doesn't really matter. I think I'll just find C. There's C right there. So sine of C over the side across from it, which is 7, equals sine of A. Now here's where I'm going to recall that number when I do the calculation, right? 95.7 divided by 9. So what are you going to do? You're going to go 7 times sine of 95.7 divided by 9, take the sine inverse, and check if you get the same number as I do. I get, just because I'm running out of room, I can't show all the steps here. We've done it enough over the last couple lessons. You should be okay with it. C is equal to, angle C is approximately 50.7 degrees. So that's that guy right there. All right, 50.7 degrees. Now, you have two options to find the third angle. You can use sine law again. And if you use sine law again, here's the thing. If you use sine law again and these angles don't add up to 180, there must be an error. If you're pretty positive you've done everything right, then you can just use the shortcut, which step 3, let's find the third angle just by subtracting from 180. But if you want to double check, if you're like, I don't know if I did everything right, try using the sine law instead to find the third angle, and then check if all your angles add up to 180. Now, you might be off by like a tiny decimal point because of the rounding, but if you're way off, then something's wrong somewhere. But we'll say we've done everything pretty well here. So to find angle B, we're just going to go 180 minus the other two angles, 95.7 degrees and 50.7 degrees. And we get about 33.6. All right. There you go. All right. Yeah, there you go. We've solved it. We found the 3 angles. All you got to remember is just start with the longest side first. Start by finding the angle across from the longest side. And that's it for cosine law. And never use cosine law more than once on a triangle, or else you're just doing way more work than is ever necessary. All right, so that's the end of lesson 6. Thanks a lot for watching. I know these are pretty brutal to watch and long, and I'm sorry that I ramble. I'm trying to do the best I can while I'm recording hours and hours of video every day for all my classes, and I don't have time to go back and fix them all up or clean them up. But if you spot an error, you think I've made a math mistake, please don't be embarrassed. I don't mind. I won't be embarrassed. I'm doing so many. There's got to be an error here or there. If I spot them, I'll post them on Edsby. Feel free to message me or just post them right on Edsby and say, there's a mistake. It's actually this. If you're sure, share the knowledge with everyone else. That's great. That's what it's all about. Hang in there, guys. Thanks a lot. I hope you're doing okay. I honestly actually do miss seeing you. And try this work. It's really important for those of you who want to continue in fields that need math, okay? So take care.